Let's review from 26th question. Which of the following is not a property of electric field lines? They do not form a closed loop. Option number D is right answer. So let's go to 27th question. Can you see A and C are equally spaced electric field lines? So EA is equal to EC, but EB will be lesser because the field lines are far away. So EA is equal to EC is greater than EB. So option number C is right answer. 28th question. The C is the right answer because the electric field line has to emanate normal to the surface, but it has to be normal to the surface and it has to terminate in negative charge. It's terminating here. Here also it is, but there are field lines going across, which is not correct. So the option number C is the right answer. So 29th question is, this is something you could not have answered. Here you have to equate, the question is about acceleration and electric field E is equal to F by Q, F is equal to E into Q, or capital E into small e. Instead of Q, you can also write small e. It has to be equated to mass into acceleration. So A is equal to capital E and small e by m. But you should include a negative sign here. And this comes in the next lesson. So I'll explain why the negative sign comes there. And that's the right answer. If you have not answered also, it's fine. So let's go to the next question. Again, the 30th question you could not have answered. You should know that the displacement or y, or the deflection in other words, is proportional to Q by m. You won't know this. Charge by mass ratio, and so whichever has got a larger deflection will have a larger charge by mass ratio, and obviously the particle 3 has been deflected largely, and so that's got the largest charge by mass ratio. Again, I'm not expecting you to have answered the 30th question. So 31st question, a plus or minus 20 nanocoulomb is separated by 5 millimeters, so it's a dipole. Calculate the dipole moment, just Q into 2A. You should get 10 to the power minus 10 coulomb meter, B as the option. 32nd question. Again, this question I don't expect you to answer. There's a Q, Q and minus 2Q placed at the corners of the equilateral triangle of side length L. The magnitude of the electric dipole moment, because for us that electric dipole moment word itself applies only for equal and opposite charge. Whereas you see there's a minus 2Q and a plus 2Q. And a minus 2Q and plus 2Q. And between them they seem to be calculating dipole moment, which itself is new to us. So okay, just let's learn it. So there's a P and angle between 60, and root 3P will be the answer for it. And P itself is either of the charge. So they're just taking Q into L. I'm surprised. Why isn't that they should have mentioned it as minus Q, then there won't be a problem. It is because it's 2Q, it's an issue. Maybe the question is wrong, or questions can exist like that, I don't know. So that is something new to us. 33rd question. What is the angle between a dipole moment? Dipole moment is from negative to positive. Okay, and equatorial line is along negative x directions. The angle between them is 180 degree. So 34th question. 34th question is the ratio between axial line and equatorial line electric field. Axial line is 2 times equatorial line. So option number C is the right answer. So let's go to 35th question. Electric dipole with the making an angle 30 torque. Making an angle 30 degree, torque is equal to P sine 30. So then that's all. You know the values, you have to substitute and get the answer. So you should get 10 to the power minus 4 Newton meter is the torque. So 10 to the power minus 4. So option number A is right answer. 36th, the dipole moment. Torque is equal to P cross E. Option number A is the answer for 36th. 37th. An electric dipole is placed in a uniform electric field, making angle theta. Stable equilibrium is at theta is equal to 0, which we know. So then option number C is the answer. 38th question. They've given the ds vector as phi I and the electric field vector. A dot product of E dot ds will give you the flux. Only I and I can be dotted, so phi 4s are 20. Normally they won't specify it as phi I. They'll say the area lies in YZ plane. Then the normal will lie in X, and so you should write it as phi I. This is such an easy sum. So the answer for this is 20 units, which is B. What is the nature of Gaussian surface involved in Gauss law by electrostatics? It's a Gaussian's law is a vector because the area is involved, area vector. So 40th question. The Gaussian surface for calculating the electric field due to a charge distribution at any surface. Gaussian surface is always spherical, no way. It is symmetrical about any distributed charge. So C would be the right answer, C. So let's go to the next question, which is the flux coming out of unit positive. Flux itself is Q by epsilon naught. Unit positive charge is 1 coulomb. So Q by epsilon naught is epsilon naught whole to the power minus 1. So B is right answer. 42nd, a charge Q is placed at the point of intersection of two diagonals of a cube. Is exactly at the geometric center of the cube. The flux coming out of one of the faces is Q by 6 into epsilon naught, which is option number A is right answer. The electric flux through a closed Gaussian surface depends upon the charge enclosed and the permittivity of the medium. So then option number A is right answer. 44th, if you see a square above which there's a plus 10 microcoulomb in space with a distance of 5 centimeter, you have to construct a cube such that the 10 microcoulomb is a geometric center, and so this becomes like the flux coming out of one of the face, which is Q by 6 into epsilon naught. You know the value of Q and epsilon naught and everything, substitute and get the answer, and the value of that has to be 1.88 into 10 to the power 5. So the option number D is the answer. 45th question, they've given this. All of them have the same charge. The flux does not depend on shape. It only depends on charge enclosed, and so it will be the same for everything. So 45th, the option number D is the right answer. 46th question, 8 dipoles are put in a box of cube. The flux coming out will be 0 because the net charge inside the enclosed cube is 0 for a dipole, and so then answer is D. The two parallel infinite line charge plus lambda minus lambda are placed with separation r in space. The net electric field between positive and a negative, nowhere between the electric field can be 0. So electric field is going to be added up. And you know that the separation between the two wires is r. Exactly midway between them, the distance will be r by 2. And we know that the formula for the electric field due to cylindrical Gaussian surface, to the thin wire is K, which is 1 by 4 pi epsilon naught into 2 lambda by r. But here r becomes r by 2. And the 2 goes up and 4 and 4 get cancelled. But like this, there will be one wire, another wire which gets added. So it will be 2 lambda by pi epsilon naught r. B is the answer. So let's go to 48th question. The two plates, each having an area A, are kept parallel to each other at a short distance d. They carry a charge plus q and minus q respectively. The electric field, the space between the plates will be 48th question. Yeah, will be q will be q by epsilon naught. Two plates of charge area are kept at parallel distance, plus q and minus q. It's like capacitor, no? Two parallel plates and region between them will have a q by epsilon naught. The electric field, the space between them, because nowhere between a positive and a negative charge can the electric field be 0. So they only get added up. It will be sigma by epsilon naught. I'm saying q by epsilon naught. It should be sigma by epsilon naught or q by a into epsilon naught. So then if you substitute sigma as q by a, we'll get option number A as the answer. So so sigma by epsilon naught, guys. Okay, so 49th question. An infinite line charge produces a field of 18 10 to the power 4 Newton per coulomb at 0.02 meter. Infinite line charge. Linear charge density lambda. You know this formula for it. Just substitute and get the value of lambda. It's 2 into 10 to the power minus 7 coulomb per meter. Option number A is right answer. Long cylindrical wire carrying a positive charge of linear density lambda. An electron E minus E with a charge and m mass revolves around it in a circular path under the influence of the attractive electrostatic force. The speed of the electron. See, can you imagine those wire here, line charge, and there is an electric field at one point, and that whenever there's a rotational motion, electron is revolving around it, there will be a centripetal force mv square by r, which can be equated to capital E into small e, or E is equal to F by Q, F is equal to A into Q. Two forces can be equated. Here you're equating centripetal force with capital E into small e. The whole lesson you just try to figure out which force can be equated to F E is equal to F by Q, F is equal to A into Q, that force. So here centripetal force is involved. So equating both of this, and E for the electric field due to line charge itself is, the formula is here. Just substitute and then thus find the value for V, and you know that V is independent of R. Can you see the velocity is R disappears, is independent of R. Speed of an electron is proportional to r to the power 0. Since there is no r there, okay, well, r and r gets cancelled here. Okay, so that's what it is. Such a beautiful question. So this covers 50 questions answers.